So in this lesson, we're going to talk about speed and velocity, learn the difference between speed and velocity, and do some practice examples on these. So speed and velocity. We know speed is the total distance you travel divided by time. It's how fast you travel the total distance, how quickly you get there. It's a scalar. It has a size only. Velocity is how fast you reach your final position. Slightly different, but the same idea. It's a displacement over time. So if the distance and displacement is the same, the speed and the velocity is the same. But remember, I started here, I finished here, and I do all of this, and I get to here. My speed, I have to calculate my total distance divided by time. My velocity will just be my displacement divided by time, final minus initial, okay? If, of course, I just did this directly, easy, straight away, speed and velocity would be the same. So, vector for velocity, scalar for speed, like we mentioned in the previous lesson. An example, I drive 50 kilometers east, turn around and drive 20 kilometers west in 2 hours. You need to find my distance, displacement, speed, velocity, and so forth. We will keep it in kilometers and we'll keep it in hours just to keep it simple. Normally you're supposed to put it in meters and seconds, but I'm not going to do that now just to speed things up a little. Before we go on, you kind of need to know the compass. We have never eat something wet. Never eat something wet. North, east, south, west. I went 50 kilometers east and then west. So I went like this, and then I turned around and went back again, like this. Something like this, okay? So, to solve it, I've got it drawn out here. 50 east, 20 west. I started here, I finished here. This would be my displacement in blue. The red is my distance. So the distance is going to be 50 plus 20, 70 kilometers. My displacement, final minus initial. Final minus initial, or you could just subtract the two. You could do 50 minus 20, nice and simple. And you'll get 30 kilometers to the east. Very nice. And average speed, you can just do distance divided by time. V equals distance divided by time, which we of course know the distance is 70. And I'll divide that by the 2 hours that I took. 70 divided by 2 is 30. Not 30, 35. And then, the average velocity, 15 kilometers per hour. How did we get that? Velocity, we still use v, it's the same, but it will be x over t. What was my x? This x was my displacement. My displacement, we was 30. We calculated that there. We was using 30. Divided by 2 hours. 30 over 2 is 15. That's how we got this answer. And I have to say to the east because I need a direction for this one as well. Sorry about that. Okay, there are two types of velocity. We have average and instantaneous. The average velocity is the total change in position divided by the total time it took. So I need to know the full velocity for the full distance I traveled. Instantaneous is just the velocity at one specific time. Maybe I want to know my velocity here. Or I want to know exactly what it is here. Maybe I sped up or slowed down. Maybe I got stuck. Maybe I wasn't moving. You could do the same thing, but for a shorter time frame. Not too important right now, but you should know the difference. Two types of motion, uniform motion and non-uniform motion. Uniform motion simply means the speed is the same, direction is the same, constant velocity. Nothing is changing. Non-uniform means it is changing. So I'll either change my speed or I will change my direction. These are the two things that can change as a result of this. Here's another example based on the previous stuff that we did. An object moves from A all the way here to B, which is over here. You have to find these things. There's a little graph that you'll get. You'll be given the graph most likely. But if I was to draw it myself, I will have my coordinate system. I will place my zero somewhere, and then I can mark the distances. So I could do something like this. And you'll have my A, I'll have my B, and I can start doing final minus initial and everything from here. I went from A to B, I went to the left. Okay, fine. So, if I wanted to find my speed, distance over time. How much is this distance? You can just count it all if you like, and you will realize that I have 20 here. So going from here all the way to here will be a difference of 20. You could do final minus initial, you'll get that. Minus 8 minus 12 is minus 20. Anyway, 20 divided by time. Remember I said in the previous lesson, if you're given 2 times, you will just simply subtract them in this case. So I will subtract the times. Final minus initial, 13 minus 5. This is always going to be a positive number because it's a scalar anyway, time. 20 over 8, you'll get your answer, 2.5 meters per second. That's the unit, meters per second. And the displacement over time is what we would use for velocity, xf minus xi. This is where the negative is important. Minus 8 minus 12, you will say minus 20 over 8, minus 2.5. The same answer, but I have a direction for this one. If it was positive, then you will just say positive 2.5, or you could say 2.5 to the right. But this time we went to the left, so I will say minus 2.5, or I will say 2.5 to the left. Easy enough. Another example here, just drawing this out for you. We went from A to B. I started at minus 5. I went to 11. So at a number line, I'm somewhere here. I finished there. I can do this. If I want to find the speed for this one, distance over time, measure how long the distance is, and then you'll subtract the 2 times again because I was given 2 times. Do I have 2 times? No, I don't. I just have this, so it's just 4. Okay, 16 divided by 4. Nice and easy, this one. 16 over 4, 4 meters per second. 16 meters divided by 4 seconds, 4 meters per second. And then if you have a displacement over time, you will do the same thing. Final minus initial, you'll realize because I'm going to the right, my answer should be positive. 11 minus 5 divided by 4. 16 divided by 4. 4 meters per second. Positive 4 or 4 meters per second to the right. Either way is fine. There's a quick graph. If you want to know which one is walking faster, what do you think? Giving away the answer now, but you can see that Raul travels the distance in a shorter time. He finishes much quicker. Kim finishes a lot later. He takes double the time. His slope is bigger, his slope is smaller, so you can say that Raul is moving faster. And that's going to take us into the graphs, which would actually be our next lesson. Thank you.